Welcome to this new episode of the Business of AI. Today we're very, very excited. We have a special guest. His name is Eric Pohlmann. He's the CEO and founder of Nerospec, an innovative technology company that is focusing on mining technology. So welcome, Eric.
Yeah, thanks for having me here, Luca. I appreciate the opportunity.
It's a great pleasure to have you here. Okay, so maybe you can tell us a little bit more about yourself, what you've been doing in the last decade or so. You have a lot of experience, and then we can jump straight into the conversation, which is about mining and AI.
Yeah, absolutely, Luca. Very happy to do that. Yeah. So in my specific case, I started working with artificial intelligence field with the German Research Center of Artificial Intelligence back in 2002 or 3 it was, where I actually started there. And I did there a smart factory automation center for digital technologies, localization, communication. And I did that a couple of years before I then moved on into management consulting and eventually came into digital applications in mining, not the factory, but into the underground machine space. And I've been in mining now far more than 10 years, and I have the honor nowadays to head up Nerospec SK, a company completely focused on digitalization of mining solutions, which is communication, it is data collection and evaluation and full machine automation, which I think we're going to touch on during this call as well.
Wonderful. So, this is the business of AI and mining. It sounds like an old business, right? But now, we have AI creeping into all different areas and all different industries. And I wonder, what is the current digitization level when we're talking about mining? Everybody is thinking about, caves and people, digging, but there's much more to that, right?
Yeah, absolutely. Digitalization is new in mining, and mining is a conservative, slow-moving industry in general, one must say, yeah. But we've actually last year done a survey, a study asking for how digital is your mine within the industry. And we found out that more than 70% of the participants are expecting digitalization to be growing in mining.
Mm-hmm.
And 75% of the participants said that digitalization, as they see it in projects, is paying off. And of those, again, more than 70% said it's pays off in less than 3 years. And the major benefits that the industry is looking for is actually around safety and productivity.
Mm-hmm.
These are the fields that are priority to the industry. And the question is, how do we get AI or digitalization to contribute values in those fields? So.
Interesting. And you were mentioning also communication. This is an area where AI and digitization can play a major role. Is that right?
Yeah, absolutely. Communication is such a critical linchpin to digital data being collected, used in communication between machines. So it's kind of the most fundamental single thing you need to get in place. And mines are remote areas in surface, but specifically underground mines, which we focus on, are, let's say, in the dark in terms of regular connectivity solutions. So we deploy specific digitalized communication solutions, Wi-Fi, LTE, right? And this is an essence, right? This is the pure essence to get going. And many mines today, in terms of their maturity on communications, they don't have those things. This is really the first starting point of getting digitalization going or AI going in mines now.
So is it fair to say that we're really scratching the tip of the iceberg at the moment with technology and mining?
It's absolutely fair to say. Most of the big mining houses have their, let's say, demonstration development center mines, so it's happening everywhere, but it's just in the exploration phase and now getting ready for deploying into practical use and also into adding value.
Can you tell us a little bit more about, what are the drivers towards AI adoption and technology adoption? Because it seems like, mining companies are getting late to the party, but they kind of need to innovate. And, you are in the best position to capture those drivers. I could mention a few that come to mind, decarbonization, transition to a green economy, supply chain disruptions, volatility in markets, especially when it comes to specific metals and specific product and goods. Can you tell us a little bit more about that?
Yeah, absolutely. I see two areas here, and the one is using data to optimize supply chain, as you referred to, which is then also the processing or after processing math of what comes out of the whole value chain of the mine as such. Where our focus really is on what happens in the mine and with the machines, right? So that section, and there the value drivers are really things around traffic congestion in a mine, right? So where is the one vehicle hindering another one, or specifically where's a chance for an accident or a proximity event between machines, right? And this is a safety value, right? So it's about people not being run over by machines or machines not running into each other. And everyone can imagine, specifically underground, there's very limited space. So these things do happen, And actually, sadly to say, either the first or the second most frequent reason for fatalities in mines, in underground mines, is vehicles, mobile moving vehicles, right? So this is a very critical, invaluable essence where intelligence can help to identify the risk areas. So to answer a question like, how frequently vehicles meet, in which location, at which times, and is that necessary? And then mines think about the traffic plans. Yeah, they optimize their traffic plans. Can they choose a different route or use a traffic light, right? And those are then tools to use. And that's a safety contribution. But the other one, Luca, I also want to mention is the OEE, the operational equipment efficiency. And specifically underground equipment is not as efficient as we all know from factories, right? Mm-hmm. We have an efficiency of the equipment of 20 to 40% in terms of its full time where it is available over 24 hours, and then the time we're using of the day to have the machinery work, right? And that is due to logistics, it's due to maintenance planning, it's due to staff availability to operate the equipment, and just understanding what's going on in this dark underground mine, right? That is where data really is a game changer. And we like to say it's like taking the lid off of the mine and looking into it and seeing what's going on in that. And then those are the starting points, right? Once we have data, we optimize those processes, and there's plenty of opportunity in safety and efficiency.
This is fascinating. I think it's it's really interesting, the fact that with Nerospec you're focusing on the operational aspect of the business. You are essentially, if I understood correctly, you look at two different entities, the machines and the humans, and then you're trying really to optimize and to secure the difficult and challenging interaction between moving vehicles. And can we call them robots? What do you think? Because essentially there are parts that are automated and are moving by themselves, right?
Yeah, absolutely. And that is then the next frontier or level to move into automation of equipment, right? So what I referred to so far is generally applies to human operated machines as well as automated machine. But then if we go deeper, focused on the AI element of robotic machines, if you want, then this is a strongly coming area in mining as well. Actually, this survey that we did last year resulted in nearly 40% of the participants saying that the biggest game changer in terms of technology for mines is going to be automation. And there's so much to say about this. Maybe first of all, the why, as I see it, it is working in a specifically underground mine is a very remote place. It's a dark, dusty, dangerous place. Yeah, no one wants to be there, right? Imagine being 700 meters under the ground in some hole and trying to do something there with a piece of machinery, right? Knowing that the biggest danger is that the roof will collapse over you. Yeah? Or there's something ongoing with the air because there are gases coming out, oxygen is not there, right? That's the life of a miner. And this is what in future AI or robot machinery machines will do much better than people. So an issue is we have scarcity of people that want to do that. Yeah. And then you have an instability in the performance of people, right? So they're too fast. They might be slamming the walls with the machine, creating some damage to it because they have some variance in how they do things. You know? And this is really motivating and mobilizing why we need robots in mining. You know?
Interesting. And what about the perception towards mining as a polluting industry, an industry that essentially is rooted in the past, that has this legacy, that is, this is not completely positive. Do you think that there is that the public opinion is shifting and understanding the real value of what the mining industry is doing? And here I'm talking about, the fact that, if we need a true green economy, and if we want to decarbonize the world and the production chains, we absolutely need more elements, like for instance copper, lithium, and to get there we need to mine more, not less. And to mine more, it means probably more technology and less humans. So is this another driver towards AI adoption?
Well, for sure, this is a growing market and growing needs, and automation or robotics is going to help having consistent 24-hour, 7 days a week performance. And actually also in environments that are harsh or without oxygen, for instance, they could even work. Then with electric vehicles, right? Coming to also the point on how new green technologies are moving into mining or into the application around the machinery. So there is interest for these environmental friendly technologies very significantly. And that also drives the need of having robotic AI type machinery ongoing, absolutely. This is really where I see things going. However, what I also want to add is that it has been generally becoming more and more need for minerals and resources. Yeah, as you said, mining is maybe seen as a critical player in environmental context, and that has been the case all the way through. Yeah. Nevertheless, until today, we realize that mining is needed to fulfill those material requirements also of the new green supply chains. Yeah? And I always like saying, if you cannot grow it, you need to mine it, right? And we're just not going to get rid of that in terms of the environmental implications. So mines and the new metals and minerals they are looking for is essential part of the green economy we're going for.
And what about the maturity of certain mines and the new mines that are are being discovered all the time. I mean, what I'm curious about is the following: is mining becoming more complicated? Is it more challenging to mine materials, or easier, or the technology makes it easier?
Generally, mining is becoming more difficult, and that is because the general materials and minerals we're looking for globally on surface are well known and explored. So we tend to go deeper. We go deeper and deeper and deeper to go where the material is. And that makes it challenging. And that makes it challenging in terms of the technology required to keep your mine up and running, stable, right? To provide power, energy, diesel, whatever you bring underground. But actually also a big one in underground applications is ventilation. So it depends on the specific mine, but it can easily be that 40% of your operational expenditure of the mine running it is just for ventilation. Yeah, the electricity and power that goes into ventilation or air conditioning. Yeah, and that is essentially required because people are underground and they need to be well served with fresh air. So it is actually a game changer if we can consider machines working underground, maybe without oxygen.
Yeah, absolutely. That would be a big step forward. But I mean, it seems pretty obvious that the benefits and the needs are there. What about the barriers? And I mean, why the mining industry is starting this digitization process only now, and not like 5-10 years ago?
Well, technology in terms of robotic mining, AI application has been adapted to use cases in mining already many years back, right? So I like to compare it with military application of robotic machinery or rockets and these things. And since that has been around, it is also in mining. So it's not completely new, but what is really new is just the development of technology that we've seen in recent years in terms of the software stacks, yeah, the hardware as well, but specifically the approach around, let's say, autonomous navigation or autonomous operation of work tasks like loading, dumping, drilling, measuring what you're doing while you're doing it. Those things have become more and more generally available, and more people understand how that works. So that's what's driving adoption. Yeah. But I think, Luca, you also asked for barriers, right? Barriers for adoption. And sure, there are things like people concerned about losing their jobs to robotic machines. Yeah? So we do have sometimes things like vandalism or lack of support in mines where you come into the implementation of this type of projects. So the solution to that is really ensuring the mindset that the machine should be doing what the people don't want to do. Yeah. And a nice example is actually driving with a truck in a very long tunnel for 45 minutes can be a very challenging thing to do for a human because it's just super boring, right? You just need to take care not running into the walls on the left and right hand side, and so there is a chance that this is very tiring and something people shouldn't be doing, right? Machines can do this better, more reliable, you know? And this is what I always try to explain people, that it is new, more exciting jobs that are more tailored to the competence of people that are getting into play through these technologies. Yeah.
And I mean, what about regulations? And you were mentioning health and safety. You do a lot of work with financial services and the healthcare companies, and regulatory barriers there are very high. The minute you are involving, you are connecting the technology to people, and the life of people depends on the technology that you're developing. Obviously, there are regulatory concerns. There's law that allows you to do things up to a certain way. Up to a certain point. What about mining and regulations? I mean, I imagine that it's kind of the same thing, same paradigm, right? The technology is there, but it's difficult. It's hard to deploy that technology in an environment which is so complicated as a mine 700 meters underground.
Yeah. Agree. Whereas I always think comparing our application cases in mining they are actually very nice compared to road vehicle automation challenges. Yeah, and the reason is it's just far less humans around in the mines. Yeah, and the roads are not so complex. You have tunnels, right? So they're predefined in that sense. And in terms of applying or regulatory approval of running these systems, I experienced that this is something that is not so highly regulated in an underground mine as you find it on a surface road condition. You need to convince the authorities of what you're doing is safe to do. And the way we always deal with it, or usually deal with it, is that we have confined spaces in which machines work, right? Like it from robots in factories, right? You have a cage around it. And in our case, in the mine, the cage is basically the tunnel. So it's already there. So you need to think about the end points, right? How do machines get in and get out, and under which conditions? Lights, sensing. We need to ensure that if for any reason they leave the confined space, they'll be shut off. So those things are actually quite well possible to manage nowadays, and with also specific mine-specific solutions. So generally said, I think the barriers there, or the means in terms of regulations to get automated systems running, that is not so much of the challenge. Yeah? It's more the people, the change management around it, the will to invest in a completely different way of doing things than they have been done so far.
And it's the usual sentence: we have always been this way. We're not going to change it.
Yeah, absolutely, Luca. Yes, that is it. Yeah,
but now we need to change, right? And I'm particularly interested to know more about this use case that you just mentioned about autonomous driving and autonomous vehicles that have an obvious benefit. It seems to me like it's a simplified autonomous driving scenario. While in the surface we have moving objects, we have pedestrians, we have traffic lights, we have roads, we have let's say unconstrained or uncontrollable lighting conditions. The degrees of freedom inside a tunnel are much less, and therefore while autonomous driving is not there yet because it's complicated, it seems like we might have enough technology to enable autonomous driving in a tunnel. Can you tell us a little bit more about this?
Yeah, absolutely, Luca. I'm exactly of the same opinion as you just described, right? I think the challenge underground is more manageable than what we are experiencing on roads. Absolutely, yeah. And just to indicate also the value it can have in terms of productivity in some implementation cases that we're working on right now, is that usually you have, if you're running 7 days a week, 24 hours, you work in shifts, right? So what happens is that between the shifts, you have shift changeovers, and then the machines are not utilized. Yeah. So maybe they drive a distance to bring the driver back to the transfer place, and then people leave the mine while the new guys come into the mine. And depending on how far away that working area is, it might be that there's 2 hours of unutilized working time. Yeah, the machine is just waiting for the next guy to come. And this is, in my eyes, the ideal scenario for applying automation technologies, AI in mining, because by definition there's no person in the mine, yeah, and it's just sitting there idle, loose to be used, yeah. And so if it's 2 hours and we have that in 3 shift changeovers per day, that's already 6 hours per day where you can use a machine where it wasn't been used earlier, so existing installed fleet. And that is actually like a third of your capacity you have today. So you can pump up capacity by a third just by using those unutilized hours.
Wow. What we just learned is that by deploying a technology that is already available, maybe even off-the-shelf technology, to a very specific use case involving essentially moving goods and from 2 points from A to B, we can increase significantly productivity. Is there any other use case that comes to mind that we can share with our audience for boosting productivity in the mine using AI or computer vision?
Yeah, computer vision is the other one I would like to talk about then there, because in terms of the technologies we use, we have in mines dusty environments. Yeah? And that means that we prefer to use radar, yeah, as a technology, or as echo sounder, yeah, to measure distance. Yeah? Whereas the advanced orientation technologies are based on light sensing solutions, LiDARs or cameras, right? And this is where we have the biggest technological challenge, to keep those type of sensors clean and running for a long-term period. And this is just a technological development edge, right, where we are at. So if you then do that with air or with a wipe or a brush or however you deal with that, those are the things we're working on to make these type of solutions work. And another technological edge is localization, or finding the position of machines. Whereas on surface, we all kind of naturally think GPS, no problem, we always know where we are and it's super exact. I think we all know in buildings it's somewhat limited, but underground, I can tell you there's no GPS. So we need to find other solutions for that. And for that, we use beacons to locate if it's Bluetooth or other technologies, and create maps based on known positions.
From what I understand, Danny, while on one end mines are a simplified environment where you can control certain aspects of that environment, like for instance lighting, they are at the same time more complicated than surface environments, because there are other aspects or elements, like for instance dust. I might even argue that noise could be another disturbing factor, especially if you're using noise sensors, or if you're using microphones for detecting certain events. So what is the current status quo when it comes to sensor technology in mines? So you were mentioning that for obvious reason cameras are difficult to use. You were mentioning LiDAR. It's probably has probably more straightforward application. Do you think there are other technologies that are being used with success, in this challenging environment?
Well, definitely, first of all, LiDAR is the status quo technology for environment sensing, spatial awareness. There's no question about that. And videos are challenging to rely on for that. But obviously also wherever we go into automation applications, videos are also made, and if it's only recording for observation and later follow-up. Yeah. And in many cases, there's also the wish to do, let's say, tele-remote operation, which is then you need to convey the video picture all the way through to a remote operator being in a different location, and which is one model of semi-automation, as I like to call it. Whereas for sure the advanced AI automation applications in this machinery area actually lives without observation and without tele-remote technologies, right? What we're all desiring for is that machines completely work autonomously by themselves, right? And ideally even without connectivity to network, because that is already a challenge or limited, right? So they need to be completely autonomous is really what it is. So
we were mentioning a set of applications and technology to improve productivity. Let's talk now about health and safety, because there are still a lot of people underground mining. So what is the current state of the art when it comes to health and safety? What are the systems that are put in place normally to guarantee that those very challenging environments are still livable?
Yeah. So here I need to refer to the standards actually set by the Earth Moving Equipment Safety Roundtable, immersed. And they actually define for this type of equipment 9 levels of vehicle intervention control, which actually describe very much safety-based. What do you need to take care of? And it starts with very basic things like your traffic management plan, your technical condition of the vehicle, your mirrors that you might have, or video cameras that you might have. But then it also goes into the procedures that you have around the operator qualification, their readiness to operate. And then it goes into supportive advisory proximity detection systems. And this is where advanced technology comes in. And there we have the level which is proximity detection that usually works on electromagnetic sensing of objects that come close to each other. But there are different technologies out there, or radio frequency transmissions. And then they indicate to an operator where an object is, if it is in front or in back, or even which direction it is. So that is common technology, well proven and developed. But if we then go a level further, what we call level 9, that is the last stage of automatic intervention before a collision happens, this level 9 proximity detection and intervention with the machine. That is the concept. So what that implies from the immersed level 9 is that then the machine slows down by itself and stops before it, for instance, hits a person. Yeah? And then individual miners, they all get, as they anyhow have a helmet and a cap lamp and a battery with them, they'll get a tag device that reacts electromagnetically or based on radio, and then indicates its proximity or closeness to a moving piece of equipment. And the machine will react on it. It slows down, it stops, and it stops that under certain given conditions. And this is really cutting edge technology. It has been actually developed strongly over the past 6-7 years in South Africa, interestingly. And a strong rationale for that is that in South Africa, we have a lot of people in mines, and sadly, we have also fatalities, incidences there over the past years. So the strive of the South African Mining Authority to change this and to bring technology into application has been strong. And there's a mining charter that regulates the requirements of these type of technologies that need to come in place for new equipment being brought into mines. And this is what we call fleet-wide collision avoidance system or vehicle intervention control. There are a couple of different names around for that globally. But this is, let's say, standard in South Africa, and we see a significant uptake of this concepts in Australia, in Canada. Yeah, those are the other two big mining areas around the world where we see them as the next early adopters of this technology.
Very interesting. And you were mentioning proximity sensors distributed on the bodies of the miners, on the equipment, in moving vehicles. So there's a lot of data, and where there's a lot of data, there's a lot of predictive power. And I was wondering if you are aware of any examples of real-time risk assessment tools that are able to flag potentially challenging or potentially risky events, and even predict, situations where humans are at risk. Is that, is that now already been deployed? Is this the future? Can you elaborate a little bit more on this?
Yeah, absolutely. So obviously mines have the same requirements and desires as you describe them right now. So what has been developed and is state of the art is that you collect of the vehicles their movement data in terms of location, and you collect what time in place an proximity event has happened. So it's not always about the accident, it's also about just when do people come too close to machines or machine comes too close to machines. Yeah? And that is statistically measured, it's captured as data, and it is reviewed and used for two main purposes. The one is really analyzing the traffic movements. And with traffic, it's not only machine versus machine, but also people. Where are people actually? And why are there? They in those locations at those times. So it is used for that traffic movement, and with that, the traffic plan improvements. So as database to do strategic decisions around traffic planning. So that is the one use. And then the other major use is to collect the data to train drivers, actually. So reviewing how things have happened in terms of either going through the traffic routes, but also how frequently events happen. And for that, there's actually another motivation to that is the use of the equipment as such. So brakes is a good example. So these overriding proximity avoidance systems, they actually break down the machines, and then operators drive against the brakes, right? Kind of, they have the machine slow them down, so they don't really care so much about it. They just drive against the brakes. So obviously you use brakes then, right? You wear them out if you do use the technology in that way wrongfully, I would say. Yeah? And so that data is also used to train drivers, to indicate to them when their behavior is not ideal for the efficiency of the overall system. Yeah.
And I wonder how you distribute the intelligence and the the computational power, because if we have a mine that is a deep mine, 700 meters underground, I mean, you're going to have on-site sensors, so sensors that are distributed all over the mines. And there are servers that are maybe local servers or on the surface servers. So there is a complex architecture to be designed and maintained. So I wonder, how do you do that? How do they implement these kind of complex systems that involve some level of distribution over the devices and also on the surface, because I imagine that the controllers are on the surface while the miners are doing their job underground. Complex communication infrastructure. Can you tell us a little bit more about that?
Yeah, absolutely, Luca. The communication infrastructure is all that it's really about. First of all, as machinery and equipment and people are moving, we need wireless communication technologies. And what we typically have everywhere is that the communication networks are not covering all of the areas in mines, specifically not underground. So that's why we need some edge computing or some storing capacity within the units themselves. So they basically capture the events, locations, events, point of time. And then once they come into network coverage, they share that data with the server, typically on surface, right? But locally hosted on the site. And that's where the first level of collection occurs. And then opportunistically, we upload to the server, and from the server into the cloud. And from the cloud, there are then analytic services. So that's the architecture, how usually these solutions are deployed. But another thing I want to add, Luca, as you asked earlier about the predictive capabilities in terms of predicting what would happen, potentially in terms of people risks or accidents. And this is the level where the industry is talking about. I think people are aware of the need and of the interest for that. But I must say, I haven't seen much well-working solutions around that. So this is truly a development area for the industry.
And what about predictive maintenance? Since we are talking about this this kind of applications where data can become an asset. Predictive maintenance in manufacturing is now delivering finally, and there are obvious benefits even in the mining industry, right? Because at the end of the day, you have a lot of equipment. Knowing when to repair or when to do some maintenance in advance can save a lot of time and money. Are you aware of any examples of predictive maintenance algorithm deployed on mining infrastructures? We're not there yet.
I must say we're not there yet. So we know it's there in factories or in big major equipment, highly valuable equipment, which is also more in the mining context than on surface in the factories. For underground mobile machinery, sure, there are some claims here and there, but I haven't really observed or seen that mines use this data. I would put it like that. Usually the more underlying basic challenges are already much bigger and more relevant to mines. And these are more simple things like, for instance, when is my next maintenance due? And a simple example like an oil change, which I would call condition-based maintenance, right? So based on the number of hours that the engine has been running, I do an oil change, right? We all know our cars are reminding us of that. This is not standard on mining equipment as such, that the machine would remind you of that, first of all. But besides, if the machine does that, this becomes a more complex alignment task in operations and the maintenance teams in mines, because the maintenance teams need to be ready for that type of service job, and the operations teams, they need to be in the position to surrender the machine for production, right? And a car is easy to surrender, right? You just say, well, okay, I get another car or I take a bus for a day, But these machines are supposed to work 24 hours a day. And if a machine is not there, then there are a couple of people that don't know what to work on, first of all, and secondly, it will have impact to your production output. So it needs to be well planned, is what I'm saying. And a fundamental thing, like just collecting the hours of all of the machines and having in a database which duration which machine needs until the next service is there and what parts you need for that service. Those kind of fundamental things are where the edge currently is in mining applications.
Eric, we're getting towards the end of this fascinating conversation. What I would like to ask you before we wrap up is, what's in the future, in the near future for Nerospec? So, what are the challenges that you see ahead, and what are the solutions that you're putting in place for that?
Well, with Nerospec SK, we're really focusing on the whole digitalization offering, and that is everything you need from a mine's perspective to make connected mining work. And that is really the communication as your backbone. So Wi-Fi LTE as the new coming technologies, leaky feeder is another one that is very essential. Then getting loggers or edge devices onto machines that collect this information and share it. That is an installation effort, right, that mines are very willing to do. And then for us, the challenge there is to make sure we cover the whole complexity of OEMs that are out there, because machines work differently, right? They have different languages and different ways of doing things. So all of that needs to be understood, and this is our masterpiece to focus on making that happening. And then also proximity detection technologies, as we mentioned earlier, and the fleet-wide integration is a challenge for mines, because a mine always runs very mixed fleets. So they're always looking for a partner in this who has actually the capability of adapting agnostically to any type of equipment that they actually have, and that will also take care of the not so easy to do machines. And this is something that the OEMs of the equipment usually don't do, right? They don't take care of your other machine, right? So mines are bound to look at integrators like we are, right? We're taking care of making these solutions work fleet-wide. And specifically with collision avoidance systems, it must be fleet-wide, because elsewise it will not work. And then finally, last but not least, it's on our roadmap is really the automation solution, let's say adaptive solution development. I like to call it automation pack, right? Your picture you need to have is that you put an artificial driver into the car or into the vehicle, irrespectively of what vehicle that is. That is the vision we're following for. And that means hardware needs to be super adaptive to what kind of machine it is. And then your software driver, or the drive stack, needs to be super adaptive as well, and learning. And this is where I see one of the biggest challenges, and back to AI challenge, which I would like to call the self-learning drive stack. What I observe in our project applications is that we have always an adaptation effort to make a drive stack work in this environment of sensors, in this environment of the tunnel. So that's state of the art. There's always some adaptation, but we're pushing and our vision is to come to a point where we have a drive stack that will just sit in a vehicle and drive it, right? Like humans do as well, with very little training.
Well, you heard it from the expert. And Eric and Nerospec are in a journey to make mines a safer, better, more productive place where we can really extract a lot of useful materials to drive decarbonization and drive the greener economy. I would like to thank you very much, Eric. This was a very interesting discussion. Our audience, I'm pretty sure, was not very familiar with the application of AI in mining, and now we really touched base on every single use case, all the technology, all the state of the art. So I would like to thank you very much, and I hope have a follow-up conversation in the future, maybe in a couple of years or even earlier, to check out where we're going with that.
Absolutely, very happy to do that, Luca. Let's meet up in 2-3 years from now.
Thank you, Eric.